Yeah, it'll do that. So I mean, you're going to see that a lot, you know. And that's something you got to watch when you're machining the rotors, because you got to work that off of there before you start machining the rotor. Because if you don't, whenever it gets to it, the machine will stop. Engine performance 1 test 17. Technician A says most fuel injection systems use the PCM to control the pulsing of the fuel injectors, and Technician B says most fuel injection systems use the PCM to control the operation of the fuel pump relay. Both of those guys are right. So you know what pulses the injector and operates the relay. There's some minor differences in how the relay gets power to its coil, but the PCM typically controls that. The following statements are correct except what?
Fuel makes contact with the injector windings.
Yeah, it doesn't. It does make contact with the fuel pump windings and the brushes, but not the injector windings. Which statement is correct?
Richard, I appreciate the help. I'd have never got it by myself.
Okay, all right. Well,
We might not have got it together.
made it happen there. Yeah. All right. Let's see. The following statements are correct except fuel makes contact with the injector winding. Which statement is correct? A, dirt is most likely to be found near the bottom of the gas tank. That's just the way it is. The fuel tank is going to have dirt on the bottom more than anywhere else because it settles out. All these methods can calculate airflow except what? What about load calculation? A, we're doing 3 tests, 15, 16, and 17. Yeah. And you'll have videos to watch. All right.
We're not done a test all week.
Huh?
We're not done a test all week.
We didn't do a test yesterday. I mean, I got us caught up on these engine performance tests because we're running out of semester, and so I had to throw a 10 question test. That's why it's just taking a long time. But we'll be through in a minute. Let me see. Which sensors used to calculate the amount of fuel required using the speed density method? Now, we remember how the fuel system works. We got, what is it that tells the computer how often, how frequent to fire the fuel injectors? What does it use for that? The frequency of the firing of the fuel injectors depends on what? Engine speed. The crank sensor is it's gonna operate the crank sensor. If you listen to them injectors, they're gonna go click, 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 and then whenever you give it some gas and speed, the engine will click, 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 they go faster. So they gotta stay caught up there, and so they can't just click at the same speed, like that. All right. So what is it gonna do? It's actually using that for a baseline, right? And so it's gonna modify the injector pulse width based on the engine coolant and the intake air temperature. A cold engine is going to need a wider pulse width. Cold air is going to need more of a pulse width. You can have an intake air temperature sensor that's telling the engine controller it's colder than it really is, and it will cause issues. And any of them that are reading them. We had this one Toyota Camry that came in here that was really, really, really hard to start. And I was looking at the fuel pulse on the scope, and the fuel pulse would be really huge. But I also noticed that the engine coolant sensor, and that one didn't have OBD2, it was an old 92 model or something. The engine coolant temperature sensor was ragged up there reading around 5 volts, which was close to 40 below zero when it was at normal room temperature. The throttle position sensor was going to make it makes it spread the pulse width, and then the map sensor. Typically, all of those are used on a speed density sense system. Now, there's speed density, there's density speed, and there's air, mass airflow, and then there's vane airflow. And vane airflow is basically got an L-shaped vane that's moved by the air, and it's hooked to a potentiometer, kind of like a throttle position sensor. And as the air, it's got a little weak spring that the air pushes, and so that was the old L-Jetronic Bosch fuel injection system that everybody so dearly loved. And those vane airflow sensors were real, real pricey. I mean, last time I priced one of those it was for a Toyota MR2 or something we were working on. They wanted $800 for one of them doggone sensors. And anyway, Technician A says all port fuel injected systems use the speed density method. He's not right. Some of them use vane airflow. Some of them use mass airflow. Some of them use density speed, right? It's all about priority, right? Technician B says all throttle body injection systems use speed density, and he's right. That'll be what you got, Cameron. Which term is used to describe pulses of air flowing from the engine out the air intake due to time interval between intake events with a 4-cylinder engine? That's a complicated question, isn't it? Which term is used to describe the pulses of air flowing from the engine out the air intake due to the time interval between intake events within a 4-cylinder engine? That is reverse airflow. I bet you hadn't ever heard of that, had you? Is that interesting? Reverse airflow. Exhaust system has got pulses in it too, and they actually use that with some little check valves and stuff to pulse air into the exhaust for,
Put that piece of paper in front of it, check for a burned valve or something.
well, sort of, yeah, but you're not going to feel this puff, puff, puff at the back of the pipe. It's such a slight pulse, you know. All right, so let's see. Which term is used to describe a system where the injector pulses once each distributor reference pulse? That's synchronized. Synchronized. And which describes a condition that delivers more fuel? Is it warm engine, hot intake air, short pulse width, or long pulse width? That's none of those other ones are right. Long pulse width is the only one where it's supplying more fuel. Less fuel on a warm engine, less fuel with hot intake air, less fuel with a short pulse width, more fuel with a long pulse width. Okay, which of these is true regarding port injection systems? The intake manifold may be shaped and sized to best fit engine performance requirements. Well, that's a no-brainer. Fuel distribution to all cylinders is equal. Let me go farther than that. Distribution of air, EGR, fuel, and everything is equal on all cylinders, right? As far as, you know, material stuff moving in there. Now, spark may be slightly different from one cylinder to the other on a real sophisticated system, but everything is supposed to have the same amount. That's how those manifolds are so specially made. They basically create a plenum chamber so that there's the same amount of pressure going into every cylinder the whole time that it's coming through there, and that's really important that that happen. All of these are correct. That's a D. Which type of port fuel injection groups the injectors into two groups, with each group firing once per crankshaft revolution? That is like the Bronco. The Bronco is a 5.8 liter engine in an 89 model, and it is gang double fired. Now, there's a couple of ways they configure those on a V8. You'll have your cylinders here on that, and some of them will have the cylinders paired up like this, and then some of them will have the cylinders paired up. See, that's right. Some of them has got the cylinders paired up with, see, this would be pin 58, I guess, and 58, and that would be pin 59, 59. So these two and these two would be fired by the same pin. Them two and them two would be fired by the same pin. Now, the other configuration that you see on that is the ones that are fired like this, like that, like this, like that. See there? In other words, you'll have the two inner ones and the two outer ones. But one way or another, these two inner ones will be connected to those two outer ones and vice versa. See that? That's how that works on some of those. But those are just about all gone. This is old. That's old technology. We've all gone with sequential fuel injection now because it's a lot more efficient and everything. Which type of port fuel injection fires all the injectors at the same time? And that's a simultaneous double fired. You know, that's two. That's just really not as efficient. Where does the fuel spray in at? Where does it spray in there at? I mean, in the grand scheme of things, does it spray right into the cylinder? It's behind the intake valve, and it sprays right before the intake valve opens, and it's stored there for a little bit, just sitting there misting around waiting to go in there. Well, see, when that air goes whooshing in there, it actually vaporizes the fuel and shoves it on in there. And you know, the spray pattern on fuel injectors is really important because it's going to have an impact on fuel vapor. Which type of fuel injection fires each injector separately following engine firing order? Is sequential. The Crown Victoria's had that back in '86 for the first time. Technician B says all injectors in a sequential fuel injection system often use the same power wire. Technician B says each injector in a sequential fuel injection system should have a different ground wire. That is true for the most part. Now, ever so often, you'll stumble across a fuel injection system that has the fuel injectors hardwired to ground, and they'll pulse power to them. And one example of that is the 87 to 90 model Jeep Cherokee with the 4-liter in it. It actually pulses power to the injector. It's a weird creature. So just remember that. But most of the time, it seems like and I say most of the time, not all the time, engineers will operate a component that's controlled by a computer by changing the state of the ground. And that's usually how injectors work. However, transmission solenoids in foreign car vehicles are power fired and grounded, hardwired to ground, which is weird, like a Nissan RE401 transmission. Something else that does that, and you might remember this, Sean, from our little experience with the air suspension. The air suspension solenoids on one of these Ford cars is basically fired up with power. In other words, they're power switched instead of being ground switched, and that's an odd situation too that I'm not kind of used to. Okay, now that is the conclusion of Engine Performance 1 Test 17.